Hi everyone. I'd just like someone to maybe let me know if you can hear me correctly, and just let me know if the volume's all good. Welcome everyone to our first onboarding webinar for the Udacity Deep Reinforcement Learning Nano degree. My name is Willie Proshek and I will be your mentor for the program. I'm really excited to be part of this and can't wait to see what you guys can achieve. First off, I'm just going to just wait a sec, let's bring it up. I'm just going to go over what we'll cover in this webinar. So what we'll be covering is I'll go a bit about, talk about myself and explain what I'll be providing to you all. Also go into some of the services, for example, Slack and some of the weekly knowledge webinars, Slack AMA sessions, mentoring virtual calls. Then I'm going to go into the course itself and just break it down, and we'll talk a bit about deep reinforcement learning itself. And then I'm just going to give you some links to some cool stuff, which I think is interesting in the deep reinforcement learning world. I'll then go into tips and tricks and then give you some additional resources that I found really, really helpful. If we've got some more time, I'll go into projects and just what I found helped with them. And at the end, I would like to have a bit of a Q&A if you guys are interested. So anything that you're not sure on that I've covered in this session and you maybe didn't quite understand, ask me and I'll try to cover it now, or I will go into it further on Slack. So next, I'm just going to tell you a bit about myself. My name's Willie Proshek. I'm an AI engineer and Udacity Deep Learning Nano degree, AI Nano degree, and Deep Reinforcement Learning Nano degree graduate. What I'll be providing as a mentor is to guide and support your learning. So part of this will be, I have been assigned 15 students in the channel, which I'll be looking after, and pretty much providing an hour webinar to go into more detail of course-specific topics. And for example, we may cover convolutional networks or PyTorch or one of the papers. I'll be providing a personalised weekly learning plan. So, my main emphasis is try to help you guys pass the course. You want to learn the content and then be able to apply it in the real world. Also, I'll be providing technical help. And you can contact me, as some of you already know, through Slack. Now, what I would also like you guys to do, if you have any questions along the way, just post them in the YouTube chat and I'll get to them at a Q&A session at the end. Probably one of the things I'd like us all to do, if we can, and if you want to, is introduce yourself on either Slack or the channel, just so we get to know who you are and so we can be a bit of a community. Also, I'd like you guys to think about what inspired you to do the course and what do you want to achieve from the course, and just tell us a bit about yourself. So I'll start. I am an AI engineer. I run a startup in Port Lincoln, South Australia. We predominantly trying to use deep reinforcement learning, and we are starting to use that in real-world problems. So one of them is the aquaculture industry of tuna farming, and we've been collecting data for about 4 or 5 years, and I finally convinced the client that we should use this data to do some incredible things. So we're trying to optimize feeding, and we're finding some really incredible results already. My background is I've been a system engineer, and I've run multiple IT businesses since I was about 19, and I basically moved over to software development and artificial intelligence a few years back. What inspired me to get into AI was the Pong from Pixels from Carpathy. So if you haven't seen that, I've got a link a bit later on in the course, the webinar. And it just did something in my head. I was absolutely amazed that you could learn Pong. I know it's quite simple now compared to what they've achieved, but I just couldn't believe it. The first thing I did was download a GitHub repo and run it, and naively thought I would run this on my laptop, no GPU, which realised it took much longer than I thought. And what I wanted to achieve by doing these courses was, I believe that deep reinforcement learning specifically has the ability to change the world for the better more than anything else, and at the same time has the ability to make the world do some dark things, so autonomous weapons and stuff like that. But hopefully there's enough of us that have learned this that want to do great. We'll be able to use this technology to do wonderful, incredible things to make the world a better place. Out of AI and out of deep reinforcement learning, my hobbies are organic gardening. I have a massive garden which I try to eat out of every day. I run a coffee business on the side because I love coffee and it tastes delicious. And I also play the piano quite a lot in a couple of bands. So I'm not just a crazy AI encoder. I do normal things out of life, out of business. Now, next, I'm just going to get on to some of the services. So as you probably already know, most of you have connected to Slack and part of the channel. This is going to be the main place where you communicate with mentors, me, and other students. You've been provided a private channel with 15 other students, and this is the students that I'll be looking after and guiding you through the course. You also have access to more generic channels, for example, School of AI, and also project-specific channels. I would highly recommend using the project channels. I found them really, really helpful when I was doing the course. When I got stuck, I would just read through comments, and sometimes I would just see something that would, tick something in my head and allow me to keep on going. Also, just check out the other channels, careers, introductions, and just all the other bits and pieces, because there's a lot of resources and a lot of questions that you might already have been answered. And do a search even, you might find the answer to a question quite quickly. And also try to introduce them to the community and be part of it, because the more I found that I got part of it, I've done 3 nano degrees, and I found that each time I participated more, I found the course much easier. And I've also, from this, I've met people that I now collaborate outside, and there's a few that have kept in contact, and hopefully we'll be able to do some fantastic things. And once again, great place to post questions and just find answers to things that you might are unsure on. But also you can talk to myself and even the other students that are doing the same material. Next, I'm going to talk about the weekly knowledge webinars. So this webinar is pretty much the first, but will be a bit shorter than future webinars. So they'll be going for about 60 minutes, and we'll go specifically into particular topics. So once again, it'll be like a paper or PyTorch or something, and go into more detail. Or, for example, proximal policy optimization, which is one of the algorithms you will learn in part 3 of the course. And great, fantastic algorithm. Go into more detail. It's pretty much my go-to. And also I'll be providing additional examples and reference material for you guys to learn and go through. So I've accumulated quite a fair bit of extra material from doing a lot of these courses, and some of the stuff really will help you in passing the projects. Next is the mentoring virtual calls. So we provide a one-on-one virtual call to each student on a weekly basis. So I'll be posting on Calendly a link for you to book your times in. If you can't make it one week, it's not, you don't have to do it, but I would highly recommend doing it. They'll be initiated on Slack, and basically the main purpose of it is to have a one-on-one communication with each one of you and be able to design a learning plan. So pretty much each week we'll review the previous week, we'll design a new learning plan for the following week, go through what you did from in that previous week, and just any questions that you might have that you haven't got from Slack, or things that you want to ask me about, technical project-related queries. The first call that we'll have, I'll have a series of questions to just find out a bit more about yourself. So just looking at that question on there. Yes, this webinar will also be recorded, and I'll post a link for that too, Thomas. So back to mentoring virtual calls. So pretty much the main idea is to try to personalise your learning rather than just a generic learning plan. And I found that working with mentors helped me a lot, and sometimes I got some incredible information from them. Now, weekly Slack AMA sessions. So once a week, pretty much we'll do an AMA session. I'm going to put a poll in Slack to find out when most of the students can actually be there. I'd like to have all of you together if I can. And this will be a place where we can just ask questions. You can ask me anything about the industry or the topics, and just go some questions that you might have. And so this will go for about half an hour, and I'm going to try to lock it into the same day, same time each week, just so it's easy. And once I know when is the best time for everyone, I'll try to put that in. The course itself. So the course is broken down into 4 main sections: the introduction to deep reinforcement learning, value-based methods, policy-based methods, and multi-agent reinforcement learning. Now, part 1 is more about reinforcement learning. So deep reinforcement learning is basically reinforcement learning using a neural network or deep neural network as the policy. Traditional reinforcement learning uses tables, and it is the fundamentals of deep learning, deep reinforcement learning. So look, really get your head around Markov decision processes and just the fundamentals of reinforcement learning, because adding the deep to it later makes it much, much easier. Now, value-based methods, which is the second part of the course, is when you get into the real cool stuff. So you'll be looking at deep Q networks, and you'll have your first project, which is a 3D maze. Sorry, not maze, a 3D world, and you collect bananas while trying to avoid blue bananas. It reminds me of Doom, and it's a good project to start off, and you'll be able to maybe implement a deep Q network or potentially even a rainbow network. Now, part 3 is policy-based. Now, they're all the rage at the moment, so they work a bit different, and you'll learn about them as you go through the course. But this involves, for example, the PPO, or proximal policy optimization, which is used by OpenAI for the Dota 1v1 and Dota 5. it's a really good algorithm, really easy to implement and works beautifully. Part 4 of the course gets a bit more into multi-agent reinforcement learning. Now, traditionally algorithms have been single agent based, but in the real world you need multi-agents, and I've already encountered that myself trying to implement certain systems for financial and other things, and a lot of effort is going into this part, and it's got quite a tough project, and you can implement this project probably about 3 or 4 different ways. They all work, but all have their ups and downs. So now that we've gone through sort of the basics of that, I'm just going to go on to the next section. So what I'm going to do is just talk about deep reinforcement learning. So if you've already started going through the course content, you've already learned a little bit about this, but I'm just going to go through it in pretty much layman's terms. So deep reinforcement learning is a subset of machine learning and artificial intelligence. Artificial intelligence is split into 2, machine learning and optimal control. Within machine learning, you have 3 main parts: supervised learning, unsupervised learning, and reinforcement learning. So supervised learning is what most people know, and if you've done deep learning, that's what you've probably done more than anything, and that involves labeled data. Unsupervised learning is unlabeled data and usually trying to find patterns in it. Well, reinforcement learning is an agent interacting with the environment. And within that, in machine learning, you have deep learning. And what reinforcement learning is the combination of deep learning and reinforcement learning. And it makes it incredibly powerful, similar to what deep learning did to machine learning. Deep learning did the same thing to reinforcement learning. And pretty much what it was able to do is generalize better. So traditional reinforcement learning, because it uses a table, you pretty much had to explore every single state and action pair to be able to have an answer. But because deep reinforcement learning uses deep neural networks, it's able to generalize, because deep learning is a function approximator. So in some ways, you maybe won't not be as precise, but for things like AlphaGo, or even just games like Sonic the Hedgehog, it will do a billion times better, and also can handle pixels and things like that. So the main part of reinforcement learning is this agent environment loop. So the agent pretty much performs an action to the environment and receives back a state and reward. The state could be joint angles of a robot, it could be pixels, it could be financial data, it could be portfolio information. But pretty much what the agent's trying to do on each loop is, and what it's trying to achieve, is to maximize the expected cumulative reward. So on the right-hand side, for example, is showing the Atari loop. So the brain, the agent, is the algorithm, so it could be a deep Q network. The actions are particular buttons or joystick movements, and the environment is the console and game. And what it receives back as a state reward is the pixels, and the reward would be the score. You can scale the reward, you can do things to it and change it and optimize it, but in essence, it's trying to maximize the reward. So if it's, for example, Sonic the Hedgehog, you'd be trying to get through the map as quickly as possible and also get a high score and not die. Now that we've gone through some sort of bits and pieces and the fundamentals of reinforcement and deep reinforcement learning, I'm going to give you guys some cool things to look at. So here are some fantastic links. So AlphaStar, if you haven't seen, is DeepMind's agent for playing StarCraft 2. I played StarCraft heavily as a kid, and I thought that it wouldn't get beaten for quite a while. They've achieved incredible results, and I'd highly recommend looking at it. Actually, I'll have a click on it now, and we can have just have a look through the post. So here's one of the links, and it basically great read. You can have a bit of a look through it, and how they implemented and what the algorithm was. Here's a bit of a show of what it's seeing and how it's kind of working. So they created two main models. One used looked at the whole map sort of zoomed out, and a lot of people were like, oh, well, that makes it easy, even though it did have the partial observation still, but they said that makes it too easy. They retrained it with one that only sees the screen, and it almost achieves the same results. So it's incredible what they've done, and I highly recommend looking through it. They've done some really, really smart stuff. Now, the other thing was Carpathy, Problem from Pixels, which I thought I'd link that in since it was what inspired me to get down this journey. The other interesting thing is OpenAI 5. So if you don't know about it, it is OpenAI's agent or bot, or whatever you want to call it, that can play Dota. He was able to completely destroy professional players in 1v1 and pretty much was on par with 5v5. It didn't do quite as well, but probably just needs a little bit more training. The other thing I would look at is anything DeepMind, so AlphaGo, AlphaZero, AlphaFold, and you'll learn about AlphaZero a bit more in the course. They've been basically, have pushed the industry in deep reinforcement learning more than any other company, and OpenAI also does that quite heavily. One of the other things I would look at while you're doing the course, or if you haven't seen it yet, or when you finish, is OpenAI Retro. It's great for playing games, and like one of the first things you'll do is Sonic the Hedgehog. I had a bit of a play with Street Fighter, which was an old game I played as a kid, Mortal Kombat, and got it to clock Streets of Rage on the Mega Drive, which was a game I played huge amounts as a kid. I did give it a slight bias in controls, giving it a move that I knew worked really well from when I was a kid, but it was able to win. It did take quite a while to train, but it's really fun to watch. The other thing which I would recommend if you've got time is I've got a link down the bottom there to the AlphaGo documentary. So it talks about DeepMind's progress of beating a professional player in Go, and the team that David Silver and that, and what they were able to accomplish, and how it changed, the Go world. It was able to do moves that people had never seen, and has made them realise that after it's one of the oldest games in the world, and there's still more to learn. So what happens probably with humans, we learn from each other, while in a sense, especially in reinforcement learning, it's probably a little bit more unbiased to a point, and it's doing some great stuff. Now, probably other things I'm just going to go through is some tips and tricks that I've learned from doing a lot of the nano degrees. If you haven't already done a nano degree, this will be new for you, and if you've done it, some of these things will be quite familiar. One of the first things I'd like to point out that there is no negative reviews. So when I say no negative reviews, is if you submit your project and it comes back and the reviewer is like, you need to change this and this, don't be disheartened. The main emphasis of doing the course is to learn and be able to apply it in real world. And the projects give you a fantastic way to see if what you've learned can be put forward. So, look at that and use it as the comments are positive. So it just gives you another way of not doing it. And also, usually the reviewer will give you some ideas of where to go. Also, if you use Slack to find answers, and one of the things I'd recommend is going, which you're already connected to, is the Udacity Deep Reinforcement Learning GitHub. Download it or pull it up, pull it down and just read through the code. Just read the code. It'll give you a good idea. The DeepQ network is really nice because it's all in PyTorch. It's much easier to read than TensorFlow. And you'll be able to find a lot of the information that you need to pass the projects from examples in there. One of the things I tend to do is when I have access to the projects, I check them straight away. I read through them, I read through the rubric, and so it's in the back of my mind when I'm doing that particular part of the course. And I may it may work for you, but I find that it just allows me to maybe jot down some extra information. Typically, once I start the project, I have to go through a lot of the course content anyway again and just get my head around a few things. But yeah, I highly recommend that. And the other thing which I would say is look at the cheat sheet and spend 3 to 5 minutes reading the notations, just so you can get your head around the algorithms and the pseudocode. The cheat sheet supplied is just a basic form, but the one that's in the Sutton Bartow, which is I think 4 pages, I would print that out and have that and look through that, because that's really detailed. And for some people, you may find that it looks like hieroglyphs. If you have a background in coding or even maths, you may find it a bit more simple, but for some people, they find it really, really difficult. The other thing is stay focused and keep inspired. So that's why I said, think about why you did this course and what you want to achieve out of it. And when it gets tough, think about that. Push yourself. And if you do get disheartened, come and talk to fellow students or myself. And we're here to help you and guide you through the course. So we want you to achieve. We want you to be able to apply this and get the job you want, or be able to make the project that you like to do. So that's something that I think is really important, and just go for it. It's amazing what you can achieve if you put your mind to it. Now, I'm just going to go over some resources which I think are important. So the Sutton Bartow Reinforcement Learning and Introduction is fantastic. It is probably the Bible of reinforcement learning. It is a tough read, I would have to admit, but it pretty much has everything. I bought the latest version recently. I think I had it on order for about 9 months, and I was just reading the PDF version online as it was getting written. The Grokking Deep Reinforcement Learning is an optional book to buy. I bought it and I absolutely love it. My partner, who hears me talking about reinforcement learning in DRL all the time, the first chapter in it, I let her read it, and she got back to me and said that was the best explanation I've found, better than anything you've been able to go through. So look, it's able to probably explain things in simpler terms and in not so sort of academic. Once again, use the Deep Reinforcement Learning GitHub. It's got amazing examples. The PyTorch examples are great. Some of the examples are a bit harder, but they are great. I really find it a good resource. Because everything you'll be doing is in PyTorch, I would recommend just going to PyTorch and just go through a few tutorials. There's also extra curriculum on PyTorch, which I recommend doing. And yeah, talking about the extra curriculum, if you do get ahead or you've got time, go through all of those resources because they are, really, really good. Once again, the cheat sheets and also the cheat sheet from the Sutton Bartow, I'd get that. Now, I've got a couple of extra links down the bottom, which I would recommend looking at. So one is OpenA baselines and stable baselines. Stable baselines is a repo that's been forked from OpenA baselines and has just made it a bit more stable, as the name suggests. I use that quite a lot to just test algorithms because, test theories, because a lot of the algorithms are quite easy to implement. The other resource down the bottom, Zhang, I think that's how it said, DeepRL, is PyTorch implementations. It's maybe not as simple laid out as the Udacity ones, but have a read. It will help you with some of your projects and give you some ideas of how to do things. Probably one of the other things I would recommend, if you're not familiar with it, is get familiar with OpenAI's Gym, because it pretty much is your go-to for all deep reinforcement learning or reinforcement learning. Even when I make financial models or anything, I use it still as the back end, because it pretty much gives you, in a sense, of the Markov decision process, or that loop, in a very simple way. Gives you the action space, it gives you the state, and you basically can implement a template to anything that you're working on. But I highly recommend just getting your head around that, how it works. And if you're already familiar, great. Just read through the docs. The docs will give you a huge amount of information. Now, last, I'm just going to go on a bit about the project. So once again, before you submit a project, go through the rubric. If everything on the rubric can be ticked off, so you go through everything one by one, you're 99.9% sure that you'll probably pass the course. The project. And because the projects are your fundamentals of passing the course, it's essential to pass them. So yeah, I systematically go through the rubric. I wasn't quite as good at it when I first started my first no degree, but now I'm systematic, and I find that I pretty much pass every project first go because I use the rubric. Once again, submissions, feedback, and reviews. Reviews are one of the best ways to find out whether you actually know what you're talking about, and I find it just a good way of knowing whether you're on the right track. Now, once again, if you get stuck, come to me. Go talk to your mentor. Talk to go on Slack. Talk to other students. Find examples. Look at resources. And one of the things that I'll do is provide probably additional resources, just some good links that I found great. Also, I think it's part of the one of the first lectures is there's a link to student resources. Great, it's a great Google Doc. Download it and use it for a lot of the resources. It's been added to much more from when I started the course. We only had quite a small amount when we were doing it, and now it's pages and pages of additional information. So yeah, once again, I highly recommend that. The final section that I've got is a Q&A. So if you guys got any questions right now, please post them and I will try to answer them. Otherwise, if I can't, I will respond in Slack maybe tomorrow or the next day. So I'll just wait to see if you have any questions. Just post your questions in the chat for YouTube if you have any. Thank you, Thomas. Well, look, if there's any other questions, feel free to ask me on Slack, or if anything comes to your mind later on or you're not sure on. I'll respond to most questions within 12 hours. I usually have Slack on while I'm doing my day job as well. So look, I'm really excited to, like I said, once again, to see what you guys can achieve. It is a really cool course, and you'll be learning pretty much cutting edge algorithms. So, proximal poly optimization and Rainbow, are my two go-tos. I use PPO with an LSTM quite frequently, and yeah, it's a great course. I was able to implement a lot of the information, a lot of the algorithms quite quickly after I finished the course, and I'm already using it in real world to you know, traditional AI information, traditional AI skill set, and deep learning. So, look, I once again excited. Can't wait to see what you can achieve, and I guess that's all for now. So, look, I will post a link to this video for anyone that's missed it, or if you want to go over it. I'll probably also click through the slideshow so you can you know, hit some of those links as well, and just help you know, help you guys understand. So I'll be getting another webinar booked in for next week, which will be a bit more course specific, and we'll be going over sort of Markov decision process and a bit more of an introduction. So we'll go into a bit more detail. Anyway, thank you very much for listening, and I will talk to you all soon. Thank you.